Good day and welcome to SCO BRICS Insight, where we look at what's really going on in the world of the BRICS. Now today I want to talk about space, and as Captain Kirk in Star Trek said, space the final frontier. Now some of you may notice that the shirt I'm wearing bears the logo of the Russian Space Center. Now, this shirt was a gift from a friend who worked at the centre training cosmonauts and astronauts to go into space, and I've been lucky enough to visit the centre many times, and I've met many people who have travelled into space, which is something I'd like to have done, but like my friend who trained the astronauts and cosmonauts, he never actually went into space himself. Now, as most of you are aware, Russia has a long and distinguished history in space exploration and research. From the launch of the world's first ever satellite Sputnik back in 1957 to the early 60s, sending Yuri Gagarin and Valentina Tereshkova into space as the first men and women ever to do so. And then, of course, in the 1970s, launching a number of successful space stations, particularly the Mir station, which preceded the current International Space Station. So today I want to talk about how Russia is continuing its space research and exploration missions. As on November the 5th, Soyuz 2.1 rocket took off from the new Vostochny Cosmodrome in the far east of Russia, which was the record number of satellites on board, 55 in fact. Now, all of these satellites were successfully entered into their designated orbits, and this launch will enable Russian scientists to resume their research into the ionosphere, which is previously inaccessible due to the various technical limitations. Now, the latest domestic devices for analysing this layer of the atmosphere were last used on the Mir orbital station, which was decommissioned, came back to Earth, and then sunk in the Pacific in 2001. Now, the ionosphere is the region of the Earth's atmosphere located between 50 and 2,000 kilometres above sea level. It contains not only neutral atoms and molecules, but also charged particles, including ions and electrons, that are formed under the influence of ultraviolet and X-ray radiation from the sun. Now, the ionosphere's ability to conduct electric current and reflect or distort radio signals, as well as influence geomagnetic activity, including the formation of magnetic storm and polar lights, makes it a crucial area of interest and study. So gaining a deeper understanding of this layer of the atmosphere will enable more effective control over radio engineering systems like radar, radio communications, radio navigations, and may even facilitate the prediction of earthquakes. Now, the hypotheses of the Russian physicist Yuri Kalinin, who suggested that the anomalies in the ionosphere occur on the eve of the strongest fluctuations, has been increasingly confirmed in recent years. Now, before I continue, I'd like to make an appeal. If you like and enjoy my videos, you can help me fund the channel and my website SCOBRICSinsight.com to further develop it. You can do this by making a small donation, which is done by clicking on the thanks button at the bottom of the screen. Now, everybody who does donate gets a personal thank you from me, and I'm actually going to thank all of you now just for watching up till this point. Now, studying the ionosphere is a challenging endeavour because it can only be accessed through the use of satellites equipped with ionosones, which are devices for measuring the parameters of space plasma. The primary type of matter in the universe, ionosones, emit short radio pulses across a wide range of particles and record reflected signals. They are utilised to assert the concentration of particles in the ionosphere and their composition and temperature, as well as the indicators of electromagnetic fields and wave radiation. Now, the first satellite to study ionosones were launched in the 1960s as a joint initiative between the US and Canada. Then, 1978, Japan launched its inaugural ionosphere into space, followed by the USSR the year after that. Then there was a further Soviet probe, and then later on even a Russian were launched. And it took measurements from the Mir orbital station, which was manned at the time. At the ultra-low altitudes, it was the first to detect denser regions with the ionosphere within diameters of 1,000 to 2,000 kilometres. Now, the formation of the disk over the Alpine Fault, which runs the length of New Zealand's South Island, has been linked by scientific papers to the magnitude 7 earthquake in the area in 1999. Now, following the Mir being discontinued, Russian scientists initiated the development of new devices for ionosphere research. But the project was only finalised at the end of 2016 when Roscosmos entered into a contract with VNM to create a space system for monitoring the helio-geophysical situation, and they got a budget of over 7 billion rubles for it. Now, the inaugural Ionosphere M probes 1 and 2 were launched into space last week. Now, the satellites were launched to an orbit of 820 kilometres using the Soyuz 2.1 rocket. Now, the equipment installed on the probes will comprehensively probe the planet's ionosphere, including the study of physical processes in plasma, the structure and dynamics of the ionosphere, measurement of the spectral gland of hard X-ray and gamma radiation in the Earth's atmosphere, and be recording the distribution of ozone. Now, the Russian Academy of Sciences plans to utilise the data to conduct ground space experiments to study the ionosphere's response to natural phenomena, such as hurricanes, volcanic activity, earthquakes and other sort of seismic events. Now, the rocket also transported 53 other additional satellites as a secondary payload, which were successfully detached from the booster and entered their designated orbit. Now, this is a new Russian record for the simultaneous launch of satellites, so you can see it's not just Elon Musk getting launched multiple satellites at one time. Now, the majority of these other devices that were launched were small. They were assembled by scientific and student teams from Russian institutes and universities. Among the satellites is the Samsat Ionosphere CubeSat. That was developed by the Gapon-Grekov Institute of Applied Physics at the Russian Academy of Sciences and the Samara National Science University. Its purpose is to measure the plasma density. Now, there's a number of satellites that have been developed in collaboration with international partners. That includes the Russian-Chinese Druzhba apparatus, which means friendship in Russian, which features a high-resolution camera developed by the Harbin Polytechnic Institute, and the Photon Amur module, which was created by the young scientists of the Amur State University in the Far East of Russia. Now, the domestic development is testing a new material for photoelectric converters, which will help reduce the cost of solar panels based on gallium arsenide compounds that are used in space today. Now, Dmitry Foreman, who's the director of the Tucholsky Scientific and Educational Unit of the Amur State University, states, if the experiments are successful, there'll be a notable reduction in the cost of satellite production. Now, the Soyuz rocket also transported the Zimbabwean satellite ZimSat-2, which is developed in collaboration with experts from the Kursk Southwest University in Russia and those in Harare. And that's going to look at remote sensing of the Earth. Now, a week prior to this momentous occasion for the African continent, Niger entered into an agreement with Roscosmos regarding the launch of 3 satellites, plus Iran's Hod for the Internet of Things and COSAR for geodesity have been successfully launched into orbit. Both those satellites were developed by private companies, according to the Iranian news agencies. Now, in 2025, the Russian space program will see the launch of 2 further probes into sun-synchronous orbit. The Ionosphere M number 1 and 4, developed by VNM with instruments from the Space Research Institute of the Russian Academy of Sciences. Now, these satellites will complete the Ionosphere Research Satellite Group, and then over the next 6 years, Russia plans to launch at least 9 more spacecraft, which include missions to explore the Moon and to Venus. So, as you can see, Russia continues to research and probe the mysteries of space. And I look forward to my next visit to Space City. Thank you for watching. Please like and share and subscribe. And if you want to help me out, press the thanks button at the bottom of the screen. Make a small donation. Don't forget to comment. Love to see your comments. Love to read them and love to respond to them. See you all again soon. Thank you.